Hello, everyone. Welcome back. Our next speaker is Sisson. Brendan is the Principal Solutions Architect of Sustainability at Amazon Web, but his experience includes being the technology strategist at Hunter Water, founder of Weathostat, and system manager and project manager at NSW DPI. Unfortunately, Brendan couldn't join us today for a live talk, so we would just have a pre-recorded session with him with no Q&A afterwards. Thank you.
Hi, thanks for joining this session on architecting for sustainability for machine learning workloads. My name is Brendan Sisson. I am a principal solutions architect at Amazon Web Services based in London in the UK. So I'll first cover an introduction to a shared responsibility model when it comes to sustainability for cloud workloads. I'll then talk through some general considerations for architecting cloud workloads, and then we'll do a deeper dive for specific considerations for machine learning workloads. So when it comes to sustainability for cloud workloads, we have this concept of a shared responsibility model where AWS is responsible for sustainability of the cloud. That's all the things such as providing energy efficient data centers, renewable energy, powering those data centers, efficient use of water, etc. And the customer is responsible for sustainability in the cloud. These are the decisions and actions that the customer can take to minimize the impact of workloads they have running in the cloud. So if we first briefly touch on sustainability of the cloud and what we're looking at in this area. First, we have the Climate Pledge, co-founded by Amazon in 2019, now with over 200 signatories. It is a commitment to reach the Paris Agreement 10 years early, so net zero by 2040. So, as I said, already over 200 signatories, and I encourage you all to consider joining that pledge. And a big part of our journey to net zero is obviously renewable energy. And we're now the world's largest purchaser of renewable energy with over 10 gigawatts of renewable capacity around the globe, powering our infrastructure, including our AWS data centers with 85 utility grade solar and wind projects. So in addition, we also have the Climate Pledge Fund, which is a $2 billion investment to invest in companies that are developing products or services that would reduce carbon emissions and help preserve the natural world. So if you're operating in this space, and machine learning workloads is going to play a big part of this. So please do reach out if this is of interest, and would love to connect you with that team. So finally, I want to call out a paper that was commissioned by 451 Research on the efficiency of the AWS cloud compared to the median enterprise data center in the US. And it found that the AWS cloud was 3.6 times more energy efficient with a reduced carbon footprint of 88% for the same workload. And this is due to a number of factors, including our ability to operate at scale with very high server utilization across the entire fleet, more energy efficient servers, efficient data center facilities, and of course that renewable energy mix that I spoke to. So because we control all of our regions and the supply chain, we can rapidly roll out energy efficiency improvements right across the world. So it's a great way to start on a journey for sustainability for your workloads. You run them in a very energy efficient environment. Okay, so let's now move on to sustainability in the cloud. These are all the things that customers can do to improve and reduce the impact that their workloads have that are running in the cloud. So when you're considering sustainability in the cloud, you can look at it from 5 different angles. So firstly, users and understanding how your users interact with your workload. Can you eliminate any unused assets? Maybe these are reports that you generate or features that are no longer required. Can you power those down? Are you matching your infrastructure with your user load? Right sizing. Have you set appropriate service level agreements with your users and not overperforming against those agreements? And the geographic placement of your workload. Are you reducing the data transfer for your end users? In software, are you running efficient code? Have you identified any bottlenecks? Are you running efficient programming languages? Are you using the most up-to-date libraries, using technologies to minimize processing your storage? So compression and working with technologies that work natively with other parts of your technology stack. In hardware, obviously you consider the right sizing, using instance types with the least impact, optimizing your use of GPUs and using managed services. So data patterns, you can, have you got a data classification policy? So how long do you need to keep the data, and what are you going to do with it through its life cycle? Can you move it to lower or more efficient energy tiers, or can you delete it after a period of time and make sure this is all automated? You want to minimize your data movements, minimize your backups, separate your compute from storage so that they can scale independently, and use a shared file system. So reducing the number of copies you have of data sets throughout your workloads. Dev test patterns, again, keeping your software up to date and even increasing the utilization of your actual build environment. So making sure it's only running when necessary and automating that process. And at a really high level, the goals for optimization are to maximize utilization of the resources that you are using and to eliminate or minimize idle resources, data processing, and data storage. Okay, so that was an overview of the shared responsibility model, where AWS is responsible for sustainability of the cloud, the customer is responsible for sustainability in the cloud, and we covered some of the things that customers can consider to reduce the impact of the in the cloud component. So now if we do a deeper dive into sustainability in the cloud for ML workloads, we'll break this up into three categories. So the typical ML ops lifecycle, data and build preparation, then we'll go through training and tuning, and finally deployment and management. So the first consideration is, do you need a custom ML model for your use case, or can you take advantage of an existing managed service that has already done the training? It's already prepared the data, it manages the updates, etc. For these common use cases, could be computer vision, anomaly detection, fraud detection. There's a whole range and a growing range of these managed services that are very highly efficient and high utilization of that data set and of the resources that went into training those. If you can't find a appropriate managed service, you can potentially look at a marketplace where you can, maybe at a minimum, take an existing curated data set that is ready to be used with your algorithm, or potentially there's already been an algorithm developed or a custom model that has been developed and that you can reuse, again removing that need to retrain and use all of the resources required for that. And of course, you can also share the work that you've done in a marketplace and help others do the same. And I spoke earlier about one of the goals being to increase utilization. So ensure that you automate your build environments as much as possible. Everything from your notebooks through to your build and tune and your endpoints. Automate right throughout the stack so that if something is not in use, it is automatically shut down and you're removing and reducing those idle, inefficient resources. Obviously, the algorithm selection is a critical component here as well. So if you're using a managed service, again, algorithms are highly tuned to their environment and are as efficient as possible. Some also offer the ability for transfer learning so that you don't have to start from scratch when you are retraining your model. You can work from the additional model that you've already produced with any new data. So it's a much higher efficient process for retraining. So data and storage is another critical component here. So look to minimize the storage that you do use for your models. Make sure you have a classification policy in place and that you're automating the deletion of data sets that aren't required, using centralized storage, something like S3, our simple storage service, and efficient file formats that work natively with the algorithm and the technology that you're using. Potentially you can pipe your data to the training systems rather than having to copy across data sets onto each instance that you're using, again, to try and reduce that data transfer. Okay, so if we now move on to training and tuning, and the first thing you consider is the use of managed services for this training and tuning component of your life cycle. So a managed service like Amazon SageMaker will automatically spin up your resources to train your models and automatically spin them down again as soon as it stops. So again, increasing that utilization. Other features such as checkpointing for retraining, so you don't have to start right from the beginning if you decide to retrain. Mentioned earlier, training on data streams and the native integration with these shared storage services such as S3. And instance selection is another large potential area for consideration. So right sizing your instance selection for your ML workloads. And you'll likely have different instance types throughout. So, there are different instance types that are more suitable for your notebook work than for your training and again for your inference. So understand each of those stages, understand the attributes you need, and take advantage of the instance selection that you have. You don't have to have one instance type to do it all. So choose the instance that's most appropriate, get that efficiency up, and remove the idle resources. And do take advantage of purpose-built silicon. So these are instance types that are created to solve very specific problems. Because we operate at such scale, we have this ability to create an instance type that is dedicated for inference workloads, and it's hugely efficient compared to general purpose GPU instances for this particular workload type. Similarly, with training workloads, we have an instance, a Trainium built purposely just for training machine learning workloads. So again, highly efficient. Encourage you to explore those options. So also consider your use of GPUs. Do you need a very high-powered machine with GPU capacity, or can you take advantage of a more energy-efficient CPU-focused machine and attach portions of GPU to that machine, elastic inference? Much more efficient, again, trying to drive at that utilization. So I spoke earlier about being able to identify bottlenecks in code and making sure that your code runs efficiently. So the same applies for machine learning workloads. So make sure you're using your debugging services, understanding are there issues in your build processes, and can you improve those and make those more efficient, and again leverage managed services for this process. Okay, so if we now move to the final section of the ML focus around deployment and management. So the first thing you can do is consider the target environment for your model. Where are you going to perform your inference, and can you compile your model to target that particular architecture? Again, making sure it's highly efficient for where that workload is going to run, and we have managed services to do that. So, SageMaker Neo can compile for a particular target architecture, making it more efficient, but also reducing the model size, and that is another consideration when you're transferring models over the air out to edge devices in a field, for example. the endpoint configuration is obviously significant here as well. So how are you managing that endpoint for your inference? Have you set up auto scaling? So can you, again, matching your user load? Can you right size your instances automatically, scaling up, scaling down the resources that you need to meet your service level agreements for inference? Can you increase utilization by running multiple models on a single endpoint? Is another example. Again, looking to drive up the overall utilization of your workload. And finally, when it comes to retraining, make sure you're using considered SLAs around the need for retraining and the improvements that you might get through that retraining process. Make sure this is data driven. So monitor your model drift and train or retrain based on that drift, rather than just having a set schedule where I'll retrain the model every day, every week, every month. Make it a data-driven decision. Okay, so we've talked about sustainability of the cloud, sustainability in the cloud. Also want to touch on the opportunity that we all have for sustainability through the cloud. This is, deploying workloads on AWS that address a sustainability challenge at your organization or in your customer base. And AWS is well placed to run these workloads. It's often a data challenge, so collecting the information from the field using IoT devices and ingesting that information in, managing and curating that data, running analytics, running machine learning for intelligence on top of that data, and then deploying new solutions. And yeah, we've got some fantastic examples of that already, and I look forward to what you're all working on as well. So a couple of quick examples might be something like CropX, so smart agriculture, where they're looking to reduce water use and increase yield, and they use these, all of the services I mentioned around data collection, analytics, and they're making fantastic improvements. Another example is in aviation with Qantas. You're doing flight route optimization using machine learning in a live environment. Obviously saving significant costs, as well, of course, as the CO2e reduction of reduced fuel consumption. So, broad range of challenges ahead of us, but I can't wait to see what you come up with. All right, so in conclusion, I hope this session was useful for you, getting a feel for how we consider the impacts of sustainability for architects. Strongly believe that developers, architects, data scientists, machine learning specialists, we all have an impact on the decisions that we make and the end impacts of the workloads that we deploy. So encourage you to make informed decisions on the architecture and the services that you use. So we have these core architectural principles: operational excellence, security, reliability, performance efficiency, cost. Now also we need to be considering sustainability as a core principle. Okay, thank you very much. I hope you enjoyed this session and enjoy the rest of your conference. Bye.
Thanks to Brendan Sisson for the great talk. Next up, we have Boban Stojanovic with his talk on operational digital twins in orchestration of renewable energy grid. So don't go anywhere. It starts at 11. See ya.